All right, so we've got this situation where S, which is the diagonal of a box, the diagonal of a box is given by this equation. Meaning if I had a box and I measured the distance from this corner to that corner, you can find it by giving the sides x, y, and z. And the question is, how is ds dt related to dx dt, dy dt, and dz dt? I'm going to make this problem slightly different to make my job easier, and then I'm going to recognize that if s is equal to the square root, that means that s squared is equal to this expression. It's sort of like the Pythagorean theorem for 3 dimensions, by the way. Right? And now I've got it in this form. It's relatively easy for me to take the derivative of this equation with respect to t. The derivative with respect to t of s squared is equal to the derivative with respect to t of x squared plus y squared plus z squared. And we get 2s ds dt, we call that the chain rule. We get 2x dx dt, 2y dy dt, and 2z dz dt.
I thought it was like if one remains the constant and, two remain constant and the third one is changing, to do for each various equation.
That would be really ugly if that was the case.
I did that.
Okay. By the way, a little bit of cleanup is in order. If you divide all those twos, if you divide by 2, all those 2's go together. And if you actually solve for ds dt, you end up getting x times dx dt plus y times dy dt plus z times dz dt, all divided by s. In the book they say, which is exactly the square root of x, the square root of x squared plus y squared plus z squared. So if you divide by s, this is s. So that's how they end up getting their answer in the back of the book.
Wow.
Is that okay there? All right. Let's call that one a close.